Welcome to our next section, Use Apache Spark in Microsoft Fabric. In this section, we're going to talk about some key elements in the Apache Spark architecture, how to configure a Spark cluster, Spark use cases, and how to use Spark to process, analyze, and visualize data. Let's begin. The process of distributing tasks and collating results is all handled for you by Spark. Spark can run code written in a wide range of languages, including Java, Scala, Spark R, Spark SQL, and PySpark. In practice, most data engineering and analytical workloads are usually accomplished using a combination of PySpark and Spark SQL. A Spark pool consists of compute nodes that distribute data processing tasks. As shown in the diagram, a Spark pool contains two kinds of nodes. One, a head node in a Spark pool coordinates distributed processes through a driver program. And two, the pool includes multiple worker nodes on which executor processes perform the actual data processing tasks. The Spark pool uses this distributed compute architecture to access and process data in a compatible data store, like a data lakehouse based on OneLake. Microsoft Fabric provides a starter pool for each workspace, enabling Spark jobs to be started and run quickly with minimal setup and configuration. You can configure the starter pool to optimize the nodes it contains in accordance with your specific workload needs or cost constraints. Note that administrators can manage Spark settings at a Fabric capacity level, enabling them to restrict and override Spark settings in workspaces within an organization. As mentioned earlier, Apache Spark is often used in conjunction with data lake architecture to process and analyze large volumes of data stored in the data lake. Use Spark and Fabric to continue transforming data or even to build a machine learning model. You submit a data processing job in the form of some code that initiates a driver program, which uses a cluster management object called a Spark context to manage the distribution of processing in the Spark cluster. In most cases, these details are abstracted, and you simply just need to write the code required to perform the data operations you need. In Microsoft Fabric, each workspace is assigned a Spark cluster. An administrator can manage settings for the Spark cluster in the Data Engineering Science section of the Workspace settings as shown here. The Spark open source ecosystem includes a wide selection of code libraries for common and sometimes very specialized tasks. Since a great deal of Spark's processing is performed using PySpark, the huge range of Python libraries ensures that there's usually a library to help with whatever the task is that you need to perform. The Spark open source ecosystem includes multiple versions of the Spark runtime, which determines the version of Apache Spark, Delta Lake, Python, and other core software components that are installed. Additionally, within a runtime, you can install and use a wide selection of code libraries for common tasks. In some cases, organizations may need to define multiple environments to support a diverse range of data processing tasks. Each environment defines a specific runtime version as well as the libraries that must be installed to perform specific operations. Data engineers and scientists can then select which environment they want to use with a Spark pool for a particular task. Microsoft Fabric supports multiple Spark runtimes and will continue to add support for new runtimes as they're released. You can use the Workspace Settings interface to specify the Spark runtime that is used by the default environment when a Spark pool is started. You can create custom environments in the Microsoft Workspace, enabling you to use specific Spark runtimes, libraries, and configuration settings for different data processing operations. When creating an environment, you can specify the Spark runtime it should use, as well as the Spark pool that the environment should use. You can view the built-in libraries that are installed in every environment. You can install specific public libraries from the Python package index and custom libraries by uploading a package file. You can specify Spark configuration properties to override default behavior and load resource files that need to be available in the environment. After creating at least one custom environment, you can specify it as the default environment in the Workspace settings. To edit and run Spark code in Microsoft Fabric, you use notebooks, or you can define a Spark job. You can run Spark in a notebook when you want to use Spark to explore and analyze data interactively. Notebooks enable you to combine text, images, and code written in multiple languages to create an interactive artifact that you can share with others and collaborate. Notebooks consist of one or more cells, each of which can contain markdown formatted content or executable code. You can run code interactively in the notebook and see the results immediately. Notebook cells contain either code or markdown text, but not both. To convert an existing code cell to markdown, select the M. To convert a markdown cell to code, select the / up at the top. Markdown cells include a text toolbar to allow you to format the text and add images. The ability to add markdown cells to a notebook is powerful. It allows you to add explanation about your code, document why certain things are being done, and define what you're trying to achieve. Not only does this feature make a notebook more useful, but it also improves collaboration. Most data engineering and analytics workloads are accomplished using a combination of PySpark, the default language for Microsoft Fabric notebooks, or Spark SQL, but you can also use Scala or Spark R. You can change the default language for a notebook, affecting all code cells, or you can use the magic command in a cell to overwrite the default language for just that one cell. For example, the %% SQL magic command changes the programming language for the cell to Spark SQL. Use the %% PySpark to change the programming language back to PySpark, or use the %% Spark to change the programming language to Scala. Note too that the drop-down menu in the bottom right of the cell can also be used to add a magic command. Remember that the magic commands are case sensitive. Code in a notebook is usually run interactively, either by running individual cells or by calling all cells in the notebook. You can also schedule a notebook to run non-interactively. If you want to use Spark to ingest and transform data as part of an automated process, you can define a Spark job to run a script on demand or based on a schedule. To configure a Spark job, create a Spark job definition in your workspace and specify the script it should run. You can also specify a reference file, for example, a Python code file containing definitions of functions that are used in your script, and a reference to a specific lakehouse containing data that the script processes. You can also specify command line arguments, which enable you to vary the behavior of the script depending on the arguments passed to it. This approach can be useful when the same Spark job will be used in multiple contexts. For example, you could use a single script to load data from files into tables, varying the file path and table name when you run it. You can also define a schedule for a notebook or a Spark job definition to have it run unattended at the specific interval that you'd like. This approach may be useful for simple automated tasks that can be scripted or which are not part of a more complex data ingestion or processing workload. In most production environments, a more manageable solution is to include the notebook or Spark job definition in a pipeline, where it can be integrated into a more complex orchestration solution. When you run code in a notebook or a Spark job definition interactively, the code runs in the security context of the currently logged in user. When you run a notebook using a schedule, the code assumes the identity of the user who created the schedule. When you run a notebook in a pipeline, the code uses the identity of the user who owns the pipeline. Regardless of how the code is run, you must ensure that the identity used in the security context has sufficient permissions to access any resources referenced by the code, including tables or files or in a lakehouse. You can use Fabric Notebook to connect to data held in Azure Blob Storage, an Azure SQL database, or other storage options. By connecting to a data source, you can use the data in analytical processes even though it isn't stored in the Fabric Lakehouse. You can also use Spark code to filter and process the data before loading it into the Lakehouse. And that will enable you to use Spark as a powerful tool here for data ingestion into the Fabric Analytics environment. The sample PySpark shown here connects to data held in Azure Blob Storage, reads data into the data frame, and then displays the data. Note the Azure Blob Storage access info at the top with the blob account name, container, and relative path. Next, see the WASBS protocol is being used to access Azure Blob Storage, pointing to the blob container name where your blob file is stored. It notes a placeholder for the Azure Storage account and the domain for the Azure Blob Storage and the path to a specific blob within the container. This URL can then be used to access or manipulate the blob. This example shows how to connect to data held in our Azure Open Dataset, which doesn't require a SAS token. To connect to your own data, you will need to generate a SAS token and then add it to the code in the appropriate places indicated here in the comments. The next statement includes a placeholder for blob SAS, or Shared Access Signature Token, that provides secure access to the blob. The previous example connects to the source data with a SAS token before reading the data into a data frame. Depending on where your data is stored, you might need to use a different authentication type, such as the Service Principal or OAuth. Lastly, it reads a Parquet file from the Azure Blob Storage into a Spark data frame, and finally displays the data frame. Working with data in a data frame within a notebook combines the interactivity of data exploration, expressive data manipulation capabilities, visualizations, collaborative analysis, iterative development, and documentation in a single environment. Natively, Spark uses a data structure called a Resilient Distributed Dataset, or RDD. But while you can write code that works directly with RDDs, the most commonly used data structure for working with structured data in Spark is a data frame, which is provided as part of the Spark SQL library. Data frames in Spark are similar to those in the ubiquitous Panda Python library, but it is optimized to work in Spark's distributed processing environment. When you load data in a Spark data frame, your schema can either be inferred or explicit. Suppose you have a comma-delimited text file named products.csv, which is a very common format. Notice that it has a header row, which includes the column names product ID, product name, category, and list price. Notice, too, that there are 3 records, each starting with a unique number, 771, 772, 773. Products.csv is located in the Lakehouse Explorer under the Data folder. In a Spark notebook, we are using the following PySpark code to load the products CSV file data into the data frame, or DF, for the path files to data. Format is set to CSV, and the header is set to true, so we can infer the schema from products.csv's file's first row or header and display 3 rows. You can also specify a schema explicitly. In the previous example, the first row of the CSV file contained the column names, and Spark was able to infer the data type of each column from the data it contained. However, you can also specify an explicit schema for the data, which is useful when the column names aren't included in the data file. Notice here that we are importing Python SQL types and functions. We're also using struct type and struct field to list out the fields we'd like to create, along with the respective data types. However, the data frame code at the bottom here is the same as before, except the header equals false. Data frame methods are functions or operations provided by a DataFrame object, and that allow us to manipulate and analyze data stored in a tabular form. You can use the methods of the DataFrame class to filter, sort, group, and otherwise manipulate the data it contains. For example, the code here uses the select method to retrieve the product ID and line item total columns from the DF framework containing product data and creates a new data frame, pricelist_DF, which contains the results of the select operation to include only the product ID and line item total columns from the original data frame DF and return only 10 records. You can also chain methods together to perform a series of manipulations that result in a transformed data frame. For example, this code chains select and where methods to create a new data frame containing the product ID and line item total columns and records where the order quantity is equal to 1 or to a 2. The result of this query is stored in the new data frame bikes_df and is being displayed here, as you can see, with 14 records shown. To group and aggregate data, you can use the group by method with aggregate functions like min, max, count, sum, average, and more. This PySpark code example counts the number of products for each order quantity. It then divides the results in the new data frame counts_df as shown here. You'll often want to use Spark to transform raw data and save the results for further analysis or downstream processing. This code example saves the data frame bikes_df as a Parquet file named bikes.parquet in the path files/product data, replacing any existing files of that same name. Up until now, we have seen many examples using PySpark. However, you can also work with data using Spark SQL. This is because the DataFrame API is part of a Spark library named Spark SQL, which enables data analysts to use SQL expressions to query and manipulate data. We can create database objects in the Spark catalog, which is a metastore for relational data objects such as views and tables. The Spark runtime can also be used with the catalog to seamlessly integrate code written in any Spark-supported language with SQL expressions. Using SQL may be more natural to some data analysts or developers. One of the simplest ways to make data in a data frame available for querying in the Spark catalog is to create a temporary view, which is automatically deleted at the end of the current session. See our example here where we create the products view in the Metastore using that create or replace temp view method. You can also create tables using the save as table method to save our data frame DF as a Delta Lake table named products. Products will be persisted in the catalog and can be queried using Spark SQL. Tables are metadata structures that are shown here since there is no explicit path listed for products table to be stored in. It will be stored in the tables folder location as a managed table in our data lake. Managed tables actually handle both data and metadata management. Remember too that deleting a managed table will also delete its underlying data. We've already noted that the data will persist if you save it as a table, but it's also more efficient to query it as a table, as well as being able to share it. The table storage also optimizes for better compression and performance and can be partitioned and indexed for improved query performance. Managed tables are also better suited for long-term storage and querying. By contrast, remember that data frames are ideal for data processing and transformation tasks and are purely in-memory structures. So the decision to create a view only available in this current session or save a data frame as a new table, which is persisted, is really based on whether or not you want to reuse it. Please note that if you need to create an empty table, you can use the spark.catalog.createTable method. Create an external table as shown here is to write a data frame DF to a Delta table and to save it as an external table in a specified location. In this case, it will be saved in the path off of the files and named My External Table. An external table is a table in a database that is stored outside the database itself, typically in an external storage system like a file system or a cloud storage. External tables allow you to query and analyze data without importing its data into the database, providing flexibility in data management. This is useful for integrating large data sets stored externally with your database operations. You can use the Spark SQL API in code written in any language to query data in the catalog. This is a PySpark code snippet that contains SQL code to query the fields product ID, product name, and list price from the products table, where the category field is equal to mountain bikes or road bikes. This code uses a SQL query to return data from the products table as the data frame bikes_df. Here is the SQL code snippet that can be used in a notebook. Simply use the %% magic command with SQL to run SQL code that queries objects in the catalog. Here we are querying the catalog field and then counting the product ID field and making a new field called product count in our results set, all from the products table, by grouping and by ordering by category. The results will count the number of products by category. One of the most intuitive ways to analyze the result of data queries is to visualize them as charts. Notebooks in Microsoft Fabric provide some basic charting capabilities in the user interface, and when that functionality doesn't provide what you need, you can use one of the many Python graphic libraries to create and display data to visualize in your notebook. You can use built-in notebook charts. When you display a data frame or you run a SQL query in a Spark notebook, the results are displayed under the code cell. By default, the results are rendered as a table, but you can also change the results view to a chart and use the chart properties to customize how the chart visualizes the data. You may also want to use graphic packages in code. This example uses matplotlib, but you can also use Seaborn and many others to enhance visualization. Most are built on the base of the matplotlib library and are rendered in a notebook, making it easy to combine code to ingest and manipulate data with inline data visualizations and markdown cells to provide commentary. Now let's take a look at how to analyze data with Apache Spark. Welcome to our lab number 2. And in lab 2, we are going to be working with analyzing data with Apache Spark in Fabric. So like we begin every lab, we're going to start off first by creating a workspace. And this workspace can have really any name you want to give it. I'm going to call this DP-700 Lab 2. And most important, we need to make certain that it has either the trial license or Fabric capacity. And I'm going to go ahead and apply this. Once that workspace is created, notice it has nothing inside of it. But we're going to make a Lakehouse to start off with. So I'm going to click on New Item. And inside New Item, I'm going to go down and select Lakehouse. And again, you can give your Lakehouse any name you'd like, but I'm going to keep these kind of together with the same name. So I'm going to create this Lakehouse, and we're going to do some notebook work inside of it in just a moment here. Now, once the Lakehouse is created, we do have some lab files that you can use, and it should be off of this link right here. So this link right here will download a zipped folder called Orders. And if you unzip that folder, it will create the Orders folder, plus it will have 3 files inside: 2019.csv, 2020.csv, and 2021.csv. So you'll want to make certain that you download those and unzip it. Then what we're going to do is we're going to go ahead and upload this time into Files, a folder, and we're going to go find that folder that we just downloaded. And it is in here, as you can see. There's orders. And I'm going to go ahead and upload it right now. That will download those 3 files. And I'll be able to see those 3 files here under orders. So there is the 2019 CSV, and if I click on it, you can see the CSV file. So it has many records in it. You can see the same thing with 2020 CSV, little preview, a lot of records in there. And then same thing with 2021. So they're all CSV files. And each of those files, as we talked about in our last lab, we could go in and we could load them to a table, make a new Delta table out of them if we wanted to do that. But what we're going to do is we're going to do in this section a little bit different, since we're going to try to work here with some Apache Spark capabilities. So we're going to work with a notebook. And I'm going to create a new notebook right here. And that will open up the notebook here inside of our Lakehouse. And there is our Lakehouse right here. I'll click on it to open it up. It might take it a moment to kind of refresh itself, but we'll see the tables and files there shortly. And what we're looking at is we're looking at our code cell, and the code cell actually has some notes in it. So we could change that out to maybe a markdown cell. It has a little bit of a different look to it, little here are formatting and text. So we could keep that. And then what we're going to do is we could edit this. We could change it back to a code cell. Notice you can go back and forth with that. But we have a number of options here. We're going to mainly be working with code cells going forward. And what we'd like to do first is we'd like to create a data frame. So to make that data frame, what we're going to do is we are going to go in and we're going to take some of our existing files here, in particular 2019 CSV, or any one of these would work, honestly. And we're going to go ahead and load data as Spark. So this is going to give us the code to be able to create a data frame from this CSV file in Spark. Notice too that we're telling it there is a header, and then we want it to display the data frame. So I'm going to go ahead and run that. And when I run that, you can see the results there eventually that it will show. Now, since this is the first time I'm running it, it's going to have to start the Spark session. So it takes it a little bit of time to start that session. Looks like it started about 4 seconds or so. So it's taking a little bit to show, but then you can see the result. So this is that 2019 CSV in more of a table view. If you can see, we can notice that right here. It's a table view. So this works out for us. But as you look a little closer to this, you may discover that the fields up at the top have kind of the name of that first record. So it looks as though we didn't have a header there. So what we can do is we can modify that first line and say, you know what? We don't have a header. So let's rerun this, but rerun it with the fact that we don't have a header. Now, I could just click on, actually, I might do that. I could type the word false here. Let's try that. It's going to replace the whole line, but I'm going to try to just type the word false. And then let's rerun this and see what happens. So if we don't have a header, what does it do? Well, it kind of does this. See how we don't have a header because that first line isn't really a header, but notice the header that it gives it. C0, C1, C2, C3. I don't know if this is any better. So what we're going to do is we're going to make a little bit of a change to this. And we're going to work with some of our PySpark SQL options here, types here. And I'm going to do this a little bit differently here. I'm going to go in and open up a new code cell. And you saw how I did that. I just hovered under the results of the last one to click that. And I'm going to paste in some of this syntax here that might be helpful. And this is to give our fields names, set them up with data types. We are using some of our PySpark SQL types here to make that happen. So that looks a little bit nicer. So you can adjust the schema as you see with that. So we have names of fields and their data types here. So that comes in handy. We could also go in and do a little modification to this. So what we've been doing so far is picking up just 2019 CSV, but we can use wildcards here. So what I'm going to do is I'm going to use a wildcard with that CSV extension there. I want to keep the old one so we can compare it if we want to do that. And I'm going to go ahead and use this example here where we're using the asterisk in front of the .csv. So I'm going to ask it for all of our CSV files. Now remember, it only is going to show us the top 1,000, but now we have a longer list here that not only shows 2019 if we dig really far down, but it should show 2019, 2020, and 2021. So I'd have to expand those rows quite a lot because these are very big table files. So you can see we can include a wildcard there with our asterisk next to the CSV. So that gives us a little bit more, bigger example of things we can do, and wildcards can be used throughout as we'll take note. The other thing I'll note here is I would like to do a little bit of filtering of this data frame here. And I'm going to do it by creating a new data frame called customers. And what I want to do is I really just want to extract the customer name and the email for this new data frame. So I'm going to go ahead and execute that. And now we should only have 2 fields returned. And we're going to have it count the distinct options too. So you can see a little bit of what we get with this. So we have it count and distinct. They're used here to provide totals for the total number of customers. And then our unique count here, as we can see. So we're just seeing the uniqueness there. So one of our emails there, so counting customers and distinct. So if there's any duplicate customers, we're only coming up with the with one of them. So you can see that. And then what we're going to do is we're going to modify this a little bit more because this still might be a very large list. So we're going to try to use a little bit of SQL in here using 2 functions, select and where. So these should be fairly familiar. And we'll add that in there. And we're going to have it select customer name and email where the item is equal to, and you can see very SQL-esque here. But now we have a little bit more of a narrow list. 133 records are returned with this. So it's just focusing in on that where clause there. So we're filtering out. So some SQL-esque commands there. Then what we want to do is we want to do a little bit of aggregation. So I'm going to come in here. I'm going to click on code. We'll open up a new cell there. And we'll do a little bit of aggregation using select and group by. So you can use that here. And with our product sales data frame, we're going to select item and quantity and group by item. So we're going to see the sum aggregate function applied to our numeric column, in this case, quantity. So we can see that there. So we have the group by method. It's grouping rows by item and then aggregating quantity. So that gives us a little look there at working with select and group by. A lot of good options you can choose in here for functions. But what we'd like to do too is we'd like to do another statement here, physically working with the Spark SQL functions. We're going to import those in with that statement at the top right there. Then we are going to have it select, and using that method, it's going to use the SQL year function, and it's going to extract the year component of order date. And it's going to put it into a new field called year, and you can see that with alias year. And then we're going to have it group by year, and then count, and then order by year. So, and then we'll have it display that yearly sales data frame. So we'll go ahead and execute that. And then there you can see the data frame that's returned there, where it's going in and it's counting, it's showing the years and then doing a count of the orders. So it's doing it by order date. So that looks good. So you have a lot of ways to work with this, working with SQL functions here, using, of course, our SQL-esque methods that are available in PySpark. So a lot of ways to work with it here that might be helpful. I'm going to scroll and talk a little bit more about using data frame methods and functions to do transformations. So that's another option. I could take some of these methods and functions and use it to transform data. So in this example here, what we're going to do is we want to create a month and year column based on the order date. And let me execute this so you can kind of see what I'm talking about. I also want to create the first and last name field from the customer name field. And then I'm going to create, I want the fields to be ordered in this order right here. So here is the year field and the month field that was created. And you can see the we're using that with column option there to kind of create some of these options for us. And the year portion is being extracted from the order date, and then the month portion from order date is being extracted. So that's how we're creating those two fields there, is from extracting from order date. And then you have the first name field and the last name field, which were not there initially, but now we have them because we took the customer name, and what we did is we split it out. We split out the first name and last name from the customer name field, and then we did not include it in our result set. And as a matter of fact, we have the result set showing sales order number, sales order line number, order date, year, month, and you can see the order that we're going in with this. So this gives us a little bit more control here. You can do some transformations, so some data frame methods for that purpose. Might find those very helpful. Now, what we might want to do at this point is maybe save that transformed data frame and maybe save it into, let's say, the Parquet format. And if we decide to do that, we have to tell it where we'd like to store it. So we are going to write and overwrite this, and you can see Parquet format there. And we're going to put it under Files, and then there's going to be a folder created called Transform Data, and then another one called Orders that we will add to this. And then we want it to tell us that it's been saved. Transform data has been saved. So we want to know that. And then we can also load data. So before we load data here, let me add that code in here to load the data. But let's check to see that these have been created. So there's the files. There, if we refresh it, and it may take a little bit, but it should hopefully refresh. I was trying to stall a little bit so we could get it refreshed there. There's transform data. So that's what we had created here. And then here's orders right below it. And then inside orders, you can see our file. That's our transformed data frame. Some of its data, it's very large, the data that it stores inside of it. So it created a number of files. And then what we'd like to do is we'd like to load a little bit more into this. So what we're going to do is we're going to go ahead and run this load statement right here. And what you'll get to see with that is this data frame here is going to give us a little bit more information. It's going to load data into those files for us. And you can see some of the data that it has added here, and it's giving us a little view of it, of what it added in. So we loaded a little bit more into orders there. Okay, so you can see a little bit of our process. We also can go in, and since we have a lot of data, what we might want to do is partition our data. So what you can do is break the data up, and maybe we want to break it up based on time. That's a very common way of breaking it up. So maybe what we want to do is have it partitioned by year and then by month. And we want to put it off of files, but then make another folder in there called partitioned data. So I'm going to go ahead and execute that. And when I do that, it's going to take it a minute or so to run here. Once it runs, then what we can do is we can see if we can see it. So I'm going to go up to Files and refresh, and we may see it come out right there. There it is right there. Partition data. So it's taking it a little bit, but you can see we have a partition there by year. And then if we go, let's say, into one of the years, you can see the months broken out there. So we have the partitions created by year and then by month. And so that's an easy way to do it here, is to do your partitions when you have a very large data set. This will help with performance. Breaking it into usually how you query for the data is helpful. So we have that. So you can see that option there. And then what we can do is we can turn around and we can load data into those partitions. So we'll go ahead and do a little loading to year 2021, and the month is set to a wildcard. And then we're going to display what we are loading into that data frame there. So you can see that. And then if I go out to some of these months, you might also be able to see that there's Parquet files inside. So this section hopefully is a little helpful, giving you an idea of how to work a little bit more here with some of our Parquet files, partitioning for performance. We always have to think about performance. That's going to be very critical. Now, the other thing we can do is we could just have it make tables for us. Now, you saw how we made tables before. We were able to go to our CSV files and we could load it directly, making a table that way. But you could also do it through your notebook. So I'm going to go ahead and add in the code here. And we have the code to create this new table. It's going to be a Delta table. It's going to be called Sales Orders. And it will be available here under Tables once this runs. We also asked it to give us information about that sales order table, which is describe extended. That's the function that we're using there to give us that detail. So down here, it's telling you a little bit about it, the fields that are involved, the data type. You can find out a little bit more about its location, the owner, the table properties a bit here. But I could also click on tables, might have to refresh it, and we should see our sales order table right there. So that's what we did. We made a Delta table using our Spark here inside of a notebook. So there's a lot of ways to make tables, as you could see. This could be a good option. We might also want to take this a step further. And maybe what we want to do now is we want to maybe load that table. So we can do that too. We created the table. Now we're going to load it with some data. Select asterisk from our Lakehouse. And we're going to push this into sales orders so we could load it very easily with that. So that's an option here. I could paste it in like that. I could put my Lakehouse in. The other way I can do this is I can go to our menu there and load data from it. So I could have done it this way or the way I just showed. So there's two ways to do it. The way I just showed was probably the better and easier option, but this is another way that I can go in and set this up. So I could run this also. Okay, so you have a lot of ways to make this happen and create that sales order, use that sales order table there. A lot of ways to do it. Okay. Now I'm going to run a little query against sales orders here. And we're going to see what's currently inside of it. And there it is right there. So this is showing you a little query against sales orders. And you can see I'm using, in this case, the magic command. So you have the 2% symbols with SQL next to it. So that's the magic command, where I can change out the language. And instead of using maybe Apache Spark, I want to use SQL. So I could use, change that language to a SQL Spark here. I could choose other languages also that work here with our notebook. And then you can see too that we're querying that sales order table that we have there in our tables folder. And we can see the output there where we're having it select the, go into the order date and pull out the year portion of the order date and put that in the field order year. And then sum unit price times quantity plus tax. And we're going to call that gross revenue. And then we're going to have it grouped by order date and order by order year. So you can run that statement, typical SQL statement there that we can use. So a lot of ways to get information. As you can see, it just depends on what language you feel more comfortable with. And you can do some variation here as we're showing. Now, what we want to do too is we want to show another query. Just kind of a basic query here, where we're just going to query for everything in our sales order table here. It's going to take it a moment, and you can see the result. So, we had a couple queries against it. This is kind of a general query against it. But what we want to do is we want to change things up a little bit. And instead of seeing the results in a table, we'd like to see it in a chart. So you have the visualization that you can do here. You could also, of course, if we had our sales order table right there, we could use that in our SQL endpoint, and we could go in and do the report in Power BI. But from here, you can see what it's going to create, and you can also see some other examples. So you can choose one of the suggestions here. You could edit what this currently is doing. You could also build your own. So I'm going to go into build your own, and I'm going to make this, there's a lot to choose from in here, but I'm going to keep it a bar chart there. I'm also going to go in and I'm going to set, I could put a title on it. I'm going to set the x-axis to item. I'm going to set the y-axis to quantity. And then it looks pretty good here the way it is, honestly. This isn't bad. You could go with this chart. Maybe you want to switch it out to something else, but this doesn't look too bad. So I could create this, but this might not be the ideal option. There's other ways we can visualize. So other ways to visualize, I could use matplotlib. And this is one of the libraries that is available to us. So I'm going to go into code, and I'm going to first run a statement here. And you're going to see how it runs first. So you can see the SQL statement in there that we're trying to run with our SQL query. And you can see the result. May not be the best to see, when you work with the data frame, the result might not be the best. But what if we took it a step further, and what we did was we got into our matplotlib library and imported that. It does require pandas, so you can kind of see we're calling pandas there also. And maybe what we do is create something like this. So that's not a bad option. We could also take it a step further and get very detailed with it. Although this is a lot of code, we could use the matplotlib here to give our chart a title, to say what we want plotted, x-axis, y-axis, the height on this, the color. We could give it labels for the different x and y axes there that we can say what kind of grid. So you can get a lot more detailed with it with matplotlib. So these might be good options for us, but it does require a lot of code. But you can get pretty nitty-gritty with it. And I might even make another option with this. So you can do this a couple different ways. But maybe what you want to do is you want to maybe change this out a little bit, although there's a lot in here that we can use to create. We can make pie charts and all that. But maybe what we want to try to do is use something that might be a little simpler syntax-wise and maybe still give us enough bang for our buck. And that is maybe working with Seaborn. Notice the syntax is pretty simplistic. And let's see the result that we get from this. And this one isn't too bad here. That one actually looks pretty nice. And it was very simplistic syntax to make this happen. So I think that's all the better, honestly. So that's an option. Let's see another Seaborn option out here that we could work with. This is a little more detail that we could give it for a bar chart. It's going to have a white grid on it. So you have some options. You can use the ones that are built in here if you'd like. We had the ability to do a chart off of some of our options there when we ran the cell. And then you could also, of course, use Power BI. And then if you'd like, you could take a dip into Seaborn or even Matplotlib as an option. Okay, so I'm hoping this was helpful. And I'm hoping to also see you in our next section. Now let's take a look at our knowledge check. Question 1. You want to use Apache Spark to explore data interactively in Microsoft Fabric. What should you create? Answer: a notebook. Number 2, you need to use Spark to analyze data in a CSV file. What's the simplest way to accomplish this goal? Answer: load the file into a data frame. Question 3, which method is used to split the data across folders by saving a data frame? Answer: partition by. In this section, we discussed how Apache Spark is integrated into Fabric, along with how to prepare to use it and configure it. We explored how to ingest, transform, and load data into a Lakehouse using Apache Spark notebooks with both PySpark and Spark SQL. We discussed creating views, tables, and data frames. We also showed how to visualize data using built-in notebook charts and other integrated graphics packages. For further reading on how to use Apache Spark and Microsoft Fabric, please see the link here. Thank you.